welcome to Elevate 2019. This presentation is C# for Power Builder developers, a gentle introduction. You will learn the basis of the C# language from the perspective of Power Builder developers. The session agenda. Introduction to the C# language. We will review the building blocks, the flow control, data structures, and principle of object-oriented programming. Then I will go through a set of real-life use cases, discuss why you, as Power Builder developers, you are now asked to learn C#, and then what are the main steps for converting PowerScript to C# Web API with the new Power Builder 2019 and Snap Develop IDE. About myself, I'm a Power Server enthusiast, Power Builder developer for over 20 years, Appian MVP, and presented many times at European Power Builder user groups and Elevate conferences. Main recent activities: a large number of migration projects from Power Builder to Power Server Web and Mobile, and also a PhD studies in machine learning and big data analytics. So let's start from the building blocks of C#. The .NET Framework is a software framework developed by Microsoft, which includes a runtime environment for creating Windows application and web services. The .NET Framework class library, abbreviated in FCL, provides language interoperability, and it is a combination of classes, interfaces, data types that provide access to the operating system functionality. And then the Common Language Runtime, CLR, is a kind of virtual machine that makes development process easier and provides services such as security, memory management, exception handling, and as such, computer code written using .NET Framework is called managed code. So FCL and CLR together constitute the .NET Framework. However, in Power Builder 2019, Snap Develop 2019, we target .NET Core, a runtime that can execute applications that are built for it. So on top of a collection of libraries called ASP.NET Core for building web application. It is a combination of two things: the .NET MVC, ASP.NET MVC, which is a web framework which implements Model View Controller, an architectural software pattern where users interact with the controller that manipulates the model, which updates the view, which in the end is what is seen by the users. And then the ASP.NET Web API, a framework for building RESTful services that are applications that use HTTP requests to get, put, post, delete data. And of course, you can develop C# Web API using several tools, IDE like Visual Studio 2017, Visual Studio Code, or the new Appian Snap Develop 2019. Snap Develop is a fantastic integrated development environment. It is included with Power Builder subscription, whereas, for example, Visual Studio is another purchase. And of course, you may argue that there is a free community edition of Visual Studio, but the requirement is that the company must generate a certain revenue. I think it's around $1 million USD per year. So unless a company is a small consulting provider or software house, they will not qualify. Snap Develop includes NuGet, the package manager for .NET, NuGet in Snap Develop enables you to search, to download, install, update, configure, and uninstall .NET packages. It features IntelliSense from Visual Studio, which helps you in writing code, because at any point in time you can just get context assistance in terms of methods, properties, events of the variable and the objects that you are just coding. And then you have Snap Objects, a runtime package automatically installed in Snap Develop, which mainly provides support for data connectivity and data manipulation. Remember, here you have a table which compares data type mapping between .NET, C#, and Power Builder. So all Power Builder data types have a corresponding data type in .NET and C#. And the table shows, first of all, the keyword for built-in C# types, which are aliases of predefined type in the .NET system namespace, and then the corresponding Power Builder data type that you know very well. So let me start from the concept of class. A class is like a blueprint of specific object. A class defines the kind of data and the functionality that their objects will have. It enables you to create your own custom types by grouping together variables and other types, methods, and events. So here we just declare a class called BMI, which stands for Body Mass Index, an example that you can find very often on the web. And it's just a public class, and you can think about a class like the equivalent to a Power Builder non-visual object. Now we'll write some implementation inside this class. So we're going to add a method, a function that is called calcBMI. It returns a float, and it takes two arguments, float as well. And then it makes some calculation inside. You can see the public is class, as well as the method, which is public. So these are called modifiers. You can have public, private, protected, internal modifiers, which are keywords used to specify the accessibility of the members of a class, like constants, like fields, like method in this case, like properties and events. Next, a field. A field is a variable of any type that is declared directly within a class or also a structure. And you can also define, for example, a field called count as a static, which is a field that has a single value for the entire class, regardless of the number of instances of the class that exist at runtime. Properties are special methods, like service count here. They are also called accessors because they offer a way to get and set private field and can have two codes inside, the get or set. If a property has the static modifier like here, you can read and write the property even if no instances of the class exist. You simply use the class name to reference a static property. If a property doesn't have the static modifier, it is an instance property. It means that you have a copy of the property's values for each instance of the class. So in this case, in this code, we have one field, one property, one method. We can add also a special method called constructor, which would be automatically invoked whenever an instance of the class is created. All these entities are called members of the class. Structures are similar to classes. They are structures, and they can contain fields and methods. They can follow object-oriented terminology, like you will see they cannot be inherited from. It's not possible overriding. They don't have the structures, but they represent a small memory footprint, so very useful in many situations. Here, value is a keyword. It refers to the assigned value. It's like a parameter for the set method. So in this structure's address, I have indeed a lot of fields and also implementations here. Now, interface. An interface in C# contains only the declaration of the methods, of the properties, and the events, if any, but not the implementation. So here in this interface movable, I just declare some methods like speed, accelerate, decelerate, start, and stop. It is left to the class that implements the interface to provide implementation for all the members of the interface. So interfaces are used because they make it easy to maintain a program. They separate the concept from the implementation. You can use enumeration. Here I can declare the days of the week, Monday to Sunday, and assign numbers to them. So I have the enumerated values and the actual numbers value. Namespace, very important. Namespaces are used in C# to organize and provide a level of separation of codes. They can be considered as a container which consists of classes, interfaces, structures, even nested namespaces. They are not quite the same, but they are similar to the PBLs, to the libraries in PowerBuilder. So my class BMI belongs to the namespace PowerBuilder user group. Using is a keyword that you use to make a namespace known to your file. Okay, your C# code is within a file, so you're gonna use the using keyword to make that namespace known to the file. This way you allow the use of types in a namespace so that you do not have to qualify the namespace every time you use it. So if you use the console class to write messages in the system console, you don't need to type every time system.console. You can just use the system namespace and type just the class console in your code. So if you put everything together, what we have said so far, you can see the Appian Snap Develop IDE. We include the standard namespace systems, which for example provides access to the console objects, which consists of methods like writeLine. And then we define our class BMI, which belongs to the namespace tutorial. Here you see the console, so when you run the code, you will get some values from the code, from the calculation down here. The main method is the program entry point. It's like the open event of the application object in PowerBuilder. Now let's talk about flow control. We start from iteration structures. The for loop, it takes three parts: the initialization of the counter, the stop condition, and the increment. You can use while with condition in round brackets, and then for each, which loops on each element in an instance, my string array, of the type that implements the system collection objects. We will discuss about collection in a few slides. And var here is a keyword, which means that the type of the local variable item will be inferred by the compiler. You don't need to declare the type of this variable. Very handy. Conditional structures. Of course, you have the equivalent of the if then else in Power Builder. It just takes the condition in curly bracket in round brackets. Be careful because the operator double equals is indeed the comparison. Okay, is the operand to check if two is the operator to check if two operands are equal or not. Then you have the switch, which is similar to the choose case in Power Builder with several case conditions, and the break is to stop a fall through conditions. Then exception, almost identical to Power Builder, so try catch and then catch the exception type. Every time that your code access, especially third-party components, external components, it's good practice to include the code within a try catch constructor. Next, data structures. So memory structures that in .NET you can use for data storage and retrieval. I will start from the simplest one, the array. You have at least three kinds of declaration. The typical one, the standard one, which is you declare the variable of type array. Be careful, in Power Builder you put the square brackets next to the variable name. Here you put the square brackets next to the data type. So animals is an array of string. And then you set item number, first item, second item, third item. Another little difference in C# structures start from the index start from 0, not 1. Second type of declaration is an inline declaration, so you declare animals as an array of string, and then in curly brackets you can, of course, they are elementary data, you can just list them all. And then even more compact, you don't need to use the new operator to actually instantiate an array. You can just write a list of elementary values. Now let me talk about list. List is the simplest type of collection, and you use the angular brackets for define any data type. So in this case, my collection is a list of car, and I instantiate my list, and I will use the add method to add 1, 2, and so on and so forth instances of cars. So the first car in my garage, the second car, third, and fourth. And it's quite interesting to see how with a for each loop you can in fact iterate through the my collection. Each item will be assigned to the variable car, and then you can access methods from the car class, for instance, toString. So very compact, yet very powerful syntax. Something more about collections. So the .NET Framework provides specialized classes for data storage and retrieval. And they are called collections indeed. They are enhancements to the arrays. In Power Builder, you have the data window that somehow is a very powerful kind, even though unique collection. And in there, you have a set of methods which allow you to treat the data inside in several ways. Array is useful for working with when you have a fixed number of objects, but with collections you can have a group of objects that can grow and shrink dynamically, which instead is a limit of the array. And you can assign a key to objects for quick retrieve, and collections are type safe because can contain only one type of data. At any point you will know what there is inside the collection. You don't need to cast or check types. There is no risk to harm the surrounding memory through the usage of variables. You have at least three groups of collections. Standard, which comes from the system collections namespace, and in there you can store elements of type objects, which is the root of every class in C#. Examples are the array list, hash table, queue, stack. So different, logical data structures. Each one has a specific correspondent collection type in C#. So it depends on the problem that you want to solve, but you have specific dedicated methods per each of these collection type. Then you have the generic collections from the system collections generic namespace, and they enhance the code reuse, type safety, and performance. For instance, dictionary of, remember, the angular brackets allow you to define any data type. So a dictionary of generic couple, usually key and value, list, queue, sorted list, and again, stack. And then you have concurrents, which are an evolution of the generic collections because they are, thread safe collection classes. Thread safety is a computer programming concept applicable to the context of multi-threaded programs. So if you happen to write multi-threaded programs, you may want to have a look at this blocking collection and of course the concurrent dictionary, queue, and stack. Concept of object-oriented programming is the next section. Let me start from inheritance. Inheritance in C#, see object as the base class of all the classes in the .NET framework. And I'd say if you want to make a comparison, if even if it's not fully precise, you can take it as a powered object in Power Builder. And more precisely, this is the ultimate base class of all the classes in the .NET framework. So the object is the root of the type hierarchy. Here you have a first class, which of course is of type object, but it is named X with a getInfo method. And then down here you derive Y from X with another, let's say, implementation of getInfo. So it's getInfo is overridden. And so when you create an instance of the Y class, you will call the getInfo methods of Y. keep in mind you can only derive from one class. So this syntax only applies to one class. And the derived class can use base, the base keyword, uh, to call the method from the base class, which has been, overridden. As I anticipated, C# does not support multiple class inheritance, but luckily interfaces are provided as a replacement of the multiple inheritance. Here I declare three interfaces and a single class, users, that inherits from the three of them. So user inherits from iname, icity, and ih. The upper letter, the initial upper letter I, is usually meant to refer to an interface. So whenever I create an instance of the class user, I can call getName, getCity, and getAge from the correspondent, interface. Polymorphism, that's a very powerful concept in object-oriented programming. It is the ability to redefine methods for the derived classes. And you have the keyword virtual, which allows you to define methods that have an implementation and provide the derived classes with the option to override it. So for method overriding, use virtual and the override modifier here. So you have a generic shape, and then when you define a circle that inherits from shape, you can override the draw method to actually write the code to draw a circle. But then when you inherit from shape the class rectangle, you want to override the draw method to actually write the code that draw a rectangle. Same for triangle. Very elegant here in the main method. The polymorphisms in the for each at the end here. It loops over the list of shapes and call the method draw, regardless the current object is rectangle, triangle, or circle. So you can call shape.draw, and shape will be in turn, first of all, a rectangle, then triangle, and then a circle. Very compact, very powerful implementation. Now let's move to the real life use cases. What do I mean? I mean, implementation of typical programming problems that you may have encountered in Power Builder, but which with built-in features of the language, they are not so straightforward solutions, or they may need external libraries or maybe even server-side components. So in this section, I want to demonstrate how simple it is to solve them in C#, and later I want to outline solutions that are available to us Power Builder developers from the release 2019. So let me start from the XML. You know that in Power Builder you can use an extension that is called Power Builder DOM. So it's an external library. And with that, you can create or parse your own XML. Of course, you have also a, a built-in support in Power Build in data window, because you have import-export methods to and from XML, as long as the XML is not complex. So it contains data which is displayable within the data window. But if you want to create complex, or if you want to read from complex XML in C#, you have a very handy system XML namespace with XML document, declaration, elements, so on and so forth, classes, which allows you, for example, to create a new XML document, specify the type, the encoding, then you create the root, and then you insert the first child, and then you have additional methods to create a set, a list of objects, and nest them in very complex format. So very simple to create, save, and import and parse XML strings without the need of any external binary library like in Power Builder. Next is the access to system properties. The environment class lets you to access a lot of operating system information. In Power Builder, you can use the environment object, but it only provides very limited system information like CPU type, operating system, or screen resolution. But here you can really access a handful of information which otherwise in Power Builder you can only access through external functions, Windows functions. Oh, send an email. That's really interesting because I bet you had a lot of time that need in your application to send emails in with interfacing to the SMTP server. So in Power Builder it's quite complicated because either you use external DLL or PBNI interface or some uh, external components, third-party softwares that you need to purchase. But in C Sharp, you have um, a legacy method, which is, by the way, deprecated. It's the system.net.mail namespace. Otherwise, you have the new mailkit.net.smtp and my message. So you create an object of type my message, you specify the recipient, the, the sender, subject, usual stuff with the body, and then if you want to send this message, you just connect to the SMTP server on a given port number with some security options. You authenticate providing your user and password. If you want, you can set a timeout and then just send. So that's very useful for sending batch emails, maybe from the server side, without the need to, you know, um, use the legacy Power Builder mail session object. Web resource. From the system.net, you have the web client object. This class allows you to, access very easily uh, in a simple way web resource. So you can download web pages or resource from the web in with very little effort. You can write encoded files because the system IO namespace provide you a set of writers, and the system.text encoding also gives you access to a lot of encoding type. Here I just want to highlight the IntelliSense that anytime gives you the list of properties, the list of methods that you can use in your implementation. So that was a list of real life use cases. Now let me open up a discussion. A discussion consists of why now as Power Builder developers you need to learn C Sharp. Why you need to care about C Sharp? Well, unless you have been doing client server over the last 10 or 20 years and your customers do not complain, of course you don't have to care about C Sharp, but the context, the architecture, and the frameworks have changed towards web architectures, mobile architectures, distributed application. So C Sharp is the way in Power Builder 2019 to implement the new breakthrough feature called C# Web API. Because there is a long history of solutions and hacks to actually move the business logic to the server, because otherwise when you compile the application, the entire business logic is within your client code. But in a lot of situations, you may want to have the code, the business logic running on the server side, especially if you are meant to build up three tiers application. And historically, in Power Builder, you could use the application server plugin for Java-based application server. But then that was deprecated. Now you can use the legacy implementation of SOAP Web Service. So you can have your Power Builder MVO and with little effort convert it into a SOAP XML web service on using the .NET engine, but it's a legacy implementation. And similarly, if you want to build up a .NET assembly, you can do. Or you can just move your code to store procedures within the database. But of course, if you change the database, you need to rewrite them from scratch. With the new C# data store, you can reuse the majority of the Power Builder data window handling, and that will be the main features in the C# Web API, because it allows you to reuse the data window components, the data window object from your client server application, but in a three-tier architecture. And the same questions and the same answer is valid if you say, but I am a Power Server developer and I already have a solution for converting my client server application to a three-tier architecture, either web or mobile. That's only partially true, because Power Server doesn't really separate out the business logic from the client app. The business logic, your MVO, is still running on the client side. The Power script becomes JavaScript, which is running on the client. Of course, Power Server in addition provides you built-in data connectivity and transaction management, data window support, caching, load balancing, a lot of advanced features which are typical to three-tier application. But the Power Builder MVOs remain client code, because in the target language in Power Server it is still running in the client. You can have workarounds to this. Historically, they are get set full state, or again, you can move the code to the stored procedure, .NET assembly, SOAP XML web service. But whenever you have codes that trigger multiple server calls, then this code needs to be further optimized. And this is the case of HeavyScript with multiple server calls, because they are typical client-server and Power Builder programming style, and they are just fine on local area network because it is so low latency, but on the internet, this is a big performance issue. So the business logic separation is the purpose of the C# Web API, with the very big plus that no unsupported Power Builder features, because C# has even a more extensive feature set than Power Builder itself, and you can expose your app business logic to the external world for integration purposes. So Power Server Web, Power Server Mobile migration efforts are not lost, but in addition, they can be complemented and integrated with the C# Web API. They can truly leverage the C# Web API functionality introduced in Power Builder 2019. So it's not Power Server versus C# Web API. You can combine them together and get the best from each of them. So my personal kickoff experience moving from PowerScript to C# Web API. So first of all, I had to take into account the differences between PowerScript and C#. Of course, the first one is C# is case sensitive, whereas PowerScript is not. And for example, when you used to manipulate string, you need to put in double quotes, backslash escape. You don't have a system level string function, but you need to use the methods from the data type and take into account the differences in the flow control. We have seen, for example, very simple one. The if then else in Power Builder needs to be a little bit converted into similar but a little bit different syntax. But more important differences to us, to Power Builder developers, are the operations that refers to data store and data window, because the data store, data window is the main component in the Power Builder language. So set item, get item, keep in mind that they do not return numbers as like in Power Builder, but the equivalent C# data store implementation returns Boolean. And the row index starts from 0, not from 1. So whenever you insert a new row, whenever you loop through a data store in C#, the first line, the first row has index 0, which affects, of course, your code, because you cannot just copy paste the PowerScript get item number to a C# get item number, but you need also to replace the first row from 1 to 0 if you directly access it. Same for set item. Also, you cannot make implicit conversion from double to integer. But this is how you learn the language. It's going through these little teeny tiny differences that you learn how to move from PowerScript to C# in your Web API, REST API implementation. And when you put all together, this process of converting PowerScript to C# is not automatic, but it's quite easy, because you see to the left, you have just a standard Power Builder function, which uses data stores, retrieve the data, and some conditions and operations. The same is on the right in C#, and which is even more compact, which is good, because compact means also more developer friendly readability. And in blue you can see the little differences when you access some information, or you want to check for a value, you need to cast some data, and overall C# data store provides almost identical API than the Power Builder data store. So your business logic is not going to change. You just need to remember the little pitfalls I mentioned you before. And do remember that in the next versions of Power Builder, you will have automated tools for converting not only Power Builder data objects into the C# data store, like at the moment, but also Power Builder MVOs into C# classes, which will simplify a lot the use of C# for your REST API. I just want to remind you once again that IntelliSense saves you a lot of time by putting what you are most likely to use at the top of your completion list. So it improves your way to write code without the need to check help and manuals. And if I can just summarize everything in one picture, which compares on the left the Power Builder IDE and on the right the Snap Develop IDE, you will see that you have a typical Power Builder application. It consists of a certain number of PBLs with data windows, NVOs, and on the right you have the corresponding application, which does the very same thing, but it follows the concept of model view controller. And what you have to do is first of all individuate identify the data objects, and you have automatic tools in Power Builder Snap Developers to convert data objects into C# data store. And this tool is called Data Model Generator. So from the Power Builder data objects, you can generate automatically the C# data store, which you can use in your code. Because whenever I use a data store, I can put the very name that I also use in Power Builder. Then the next step, and at the moment, let's say it's what takes most of the time in this process, is convert your business logic, which is the, the, which is done which is implemented by the NVOs and the functions in the NVOs into the corresponding, C# classes. So in this case, my NVO needs to be replaced by the corresponding C# implementation, and here you have to convert PowerScript into C# following, suggestions and paying attention to the pitfalls that have been outlined so far. And the last step, of course, is the connection to the database. Usually the transaction objects becomes very easily what is called the data context. You put everything together and your NVOs, your Power Builder, non-visual object and business logic becomes an equivalent REST API which follows the model view controller pattern. So what is next? Next is, with this learning in mind, you're ready to create your first C# Web API with the new Appian Snap Develop 2019 IDE. Thank you very much for your attention. So stay tuned, stay connected with the community, all the Appian um, source of information on the website. Thank you.